Bismillahirrahmanirrahim. Assalamu alaikum wa barakatuh, and very good afternoon. Welcome to AMURI lecture series. Today's lecture is about the title is Dust Impact on the Performance of Solar Photovoltaic Module, History and Prospect. This lecture will be delivered by Dr. Hussein Kadam from Sohar University. Dr. Hussein is one of the elite researchers in the renewable energy with emphasis on the photovoltaic research. He has extensive research in this domain, and he has significant contribution to Oman renewable energy research. It is ready to find, let's say, if you search for any, for Oman, if you just write those two keywords, Oman and renewable energy, certainly you will find Dr. Hussein research publication as outcomes within the results you are going to obtain. So it is really our pleasure to having Dr. Hussein to deliver this interesting speech to our students and to our colleagues, our guests at Muscat University. So without any further delay, I would like to invite Dr. Hussein to deliver the speech and to get more informative, for sure, informative insight and more key ideas from what we are going to listen. So please, Dr. Hussein.
Thank you very much. Thank you, Dr. Ma'an, for introducing me. Really, it's my pleasure to participate again with the Muscat University and talk with you and share with you some of our research conducted in the field of solar photovoltaic. Our talk will be about the impact of dust on photovoltaic. I mean, I'm working with my group for a long time, around 2 decades on this topic. And because it's one of the, let me say, important problems facing this technology in the region, in the Gulf region, Middle East in general. So we've been conducting research related to dust as a part of our research field. Our presentation, I'll try to finish early to give you time to ask, because I think with the questions coming from your side, we will have more expansion to the information and to the scope. I will give just brief about our research activities in Sohar University related to solar energy. So I will talk about the concept and the principles related to dust and its impact on photovoltaic, the dust impact itself, and the status, critical review, prospect, and conclusion. Now, in Sohar University, actually, we have the first course in renewable energy in Faculty of Engineering. 2007, we started this course, and then we start establishing our lab. Important improvement happened in 2011 when we got a grant from Research Council of Oman to investigate solar photovoltaics, looking from technical, economic aspect. It was an opportunity for us to have equipment for our students to practice, to let me say, do their projects related to the course. And also we establish renewable energy labs, 3 labs, plus 1 lab for the advanced research in solar photovoltaic. Now, this is the location given to us in 2011, and then we start arranging this outside, and this is inside the place on the top of engineering building, which is Barka building. And then we try to split it into different labs, do the required installation of electricity, painting, glasses, and doors, lab, until we got the lab furniture here, as you can see, and a trunk for the cables to come inside the lab. And it took from me maybe 1 year to establish this lab. This is ladder because we will put the solar photovoltaic in the other systems in the other side of the roof. And then here we started doing the concrete after we designed the system, using the trunk to the other side of the building, and then move it to the right location. And then also the weather station, I start working on weather station here with 13 different sensors related to environment, because we need to link between environment and the technology and how it behaves. And then this is our weather station, the first one. Now we have 3 weather stations today. This is on the top of the lab, solar energy, advanced solar energy lab, and some of the concrete to be done on the building, on the roof itself, as you can see here. And then we start do the orientation according to the design. And then, by the way, students participate in all the stages, and it was an opportunity for them to learn how to design and establish or install solar photovoltaic systems. And then here the group working with me at that time to establish the working outside the lab, inside the lab. We have the equipment, batteries, charger controller, data logger, and here we have a lab complete, good with good up-to-date infrastructure in the field of solar photovoltaic. Some of my colleagues also working with me at that time, as you can see here, and we got, let me say, a lot of results through the years. And we look to the design, we look to the effect of irradiance, temperature, humidity, dust, and we try to link between them. Many results have been published, as I will mention later. And then it's not only one side view as people do, but we look from different side view, from the load side view and from the source side view. And we got interesting and important, let me say, results related to photovoltaic and how we use them in Oman different systems. Maybe I may mention one of the important achievement is the design parameters, optimum design for Oman. We published book at that time from the results, and also patent where a software in the MATLAB, let me say, umbrella, which is connected to the weather station to design any type of solar photovoltaic. And we publish many publications in a journal, conference, proceedings, books, chapters, patents, groups for final year projects, and training many final year students from different specialties, besides many visitors coming, especially students, thousands of students through the 1 decade they came to visit this lab. Now, after this brief, so you know now we have different side of view for the behavior of photovoltaic, but I will focus mainly here in this presentation only on one, which is the impact of dust. As a beginning, and just to introduce the topic itself, you know that the solar cell is, I mean, you already, I think some of you already is, attended course in Noble, so they have information about solar. But just in case if somebody don't know about the solar cell manufactured from silicon, the second material available in our nature, and so proven through the years, more than 100 years back since they manufacture it. And they have different technology, polycrystalline, mono, amorphous, and there are many within each one of these categories. And they model it by, at that time, by the one diode model they put by Shockley, Berdine, Aberdeen. It's the same model for p-n junction using transistor, and they won Nobel Prize in maybe I don't remember exactly the date, 1958 or something. Anyway, this model even used until today by software, by designers. These cells, we can put them series and parallel to make sure increase the power, current, voltage, energy. And also they put these panel modules in together in series. That we have a panel, put them in series and parallel. Then we have array or plant, solar plant or matrix, sometimes they call it, to increase the energy in general. As example, we have in Oman many power plants, talking about some of them in kilo, some of them in mega. Example, Hebri, 500 mega, Qabas Suhar, 25 mega, and many other to come in Munah, Adam, and other places, locations. The relationship or the characteristics which represent the important relationship is between current and voltage, represented by IV characteristics, as you know. And this is current, this is voltage. And based on the solar radiation, this curve could take different shape, but still it's the same relation. When current is high, voltage is low. When voltage is low, high, current is low, and open, short, and open circuit respectively. And the relationship represented by fill factor, which is the I maximum, V maximum of I short circuit, V open circuit. And it's usually in the range of 0.7 or 70%. I mean, this is a good quality cell. Reducing it mean that the quality is less. And considering the effect of shunt resistance and series resistance, the previous equation improved to be in this shape. Now, dust, as you know, our region is one of the problems is dust, and the second one is temperature difference. But this is the main, and this is our solar plants we have here systems in Sohar University. You can see the dust accumulated on regardless if it is in summer, in winter, if it is regards the season, regardless the tilt angle. At the end, dust is there in our environment and it's accumulated with time. Some places they suffer from dust, okay, and even some places you can monitor the dust storms from the space, from the using the satellite. Now, why dust accumulated? For many reasons, and what if we would like to classify the the sources for dust to accumulate on PV, we can put them in three categories, either because of environmental factors, or due to the installation, or type of dust itself. For environmental, as example, wind. If it is windy, it's different from it is calm, because windy will bring dust from location, far location, to put it there. So this is example. Wind direction also affect, temperature affect, radiance, air pollution, air pressure, humidity, dust storm themselves. By the way, because of limited time, I will not go deeply in this, in each one of them. Otherwise, in each one of them, there is a lot to say, and we did a lot of research related to each one of them. For design, we know that PV model type, it's related. I mean, when we use polocrystalline, it's different from mono. We prove this, by the way. Most of these ideas, we prove them experimentally. Okay, installation site itself, it's different when you put it near in the desert. I mean, because of sand there and dust, or you put it near, let me say, agriculture location, or near the cities themselves. Tilt angle, height, orientation, exposure time, latitude, longitude, PV front. So all these are elements related to the installation, okay, affecting how much dust deposit on the PV. Beside, type of dust. I mean, you know that if you are close to the refinery, you have more carbon, or highway. If you are close to the desert, you have sand. If you are close to the agriculture place, sometimes you see rich soil, and so on. So based on where you will put your solar plant, solar module, well, you have different effect. And before I go for the effect itself, it's worth to mention that the researcher globally, they investigated dust either using in outdoor or indoor or both, okay, which is limited. For both is limited. For outer, what they put usually, they put different panels. They try to make one clean and one dusty. These are the accessories, DC converter, but regardless what they are, but the focus here on one clean and one dusty, and they monitor. Okay, sometimes the dust could be natural dust, or artificial. I mean, natural dust, airborne dust coming with wind, and artificial, you throw it on the in a way, okay, in scientific way, you throw it on the panel, and then you measure, you take measurement, and then you compare and you come up with the correlation. These are some of the system we use them. Most of them are grants, either from Ministry of Higher Education, TRC, in the past, or even from Sohar University, to work on this effect, dust impact. Or we have indoor. Indoor, it means inside the lab, where we control the other environmental parameters, such as wind, such as temperature, such as humidity. We have a solar simulator, which is reflecting the solar radiance, and we have the panels, and then we can do our experimental work. These are some of our systems outside Oman, by the way, and other collaborators, our colleagues. And this is the data acquisition, monitoring system, sensors, and so on, to take the measurement of the current voltage, current power energy. Now, the dust impact, dust, when it comes to the, you know that the panel have a glass on top of it. This glass, the dust accumulated on it. Now, type of glass is important. The how we what is the tilt angle we put, the slope, and many other, as I mentioned, parameters affect. But simply, when dust accumulated on the panel itself, it's to prevent light to arrive to the cell inside the panel, and it's make like a shadow. Okay, so less solar radiance insulation, less photon and photon flux, so less power production. It could be different type. By the way, people sometimes they confuse between dust and sand. They are different. Dust is a scientific name for all these type of pollutants, environmental pollutants, which is in the range of. By the way, some of them they say less than 200 microns. Some of them still there are two opinions here. 500 micrometer. Anyway, it could be let me say bird drops. Some of them also they stick to the panel, difficult to remove. Or as example, algae near let me say the sea or the forest, and sometimes it could be if we put it near the industrial area or refinery or highway even. We have engine exhaust. I mean, if it's close to the agriculture rich soil and so on. So type of dust accumulated related on the related to the location and what is near to that location, and its effect is different because they are different. But at the end, they make a shadow. Here are some of the dust we used, artificial dust available in nature. We tested them. As example, as you can see, sand, cement, limestone, silica gel, iron, and each one of them, there is a reason why we select this or that. I mean, example, sand, because we put it near in the desert, as example. Okay, silica gel, there is as example, or carbon, sorry, calcium carbide, as example, when we have buildings and new places to be built. Sawtooth, sawdust, or fly ash here when we have forest and there are fires and places where we come up with carbon to be fired, and so on. So each one of them have different effect as a dust, have different effect on the PV. These are some examples of the results coming from, just to show you that the power here, if you see here, P with respect to normalized value, regardless the rating of the panel itself or the module. And here is the dust accumulated density gram per square meter. The trend is going down. Relation is decay. Regardless the solar radiance, this is measured as solar 195 watt per square meter. But you can see here, increasing the dust itself, increasing, look to the curves, increasing the reduction will be more. And even here, as you can see here, limestone, we talk 50, 60, 80. We can see here with 80 is higher, more, let me say, reduction. So the trend is reduction. And by the way, the type of, as I will mention later, the type of dust itself also have effect. It means 5 gram from carbon is different from 5 gram from cement. Their effect is different. And this is the reduction increase, as you can see here, increase with the accumulation for the same previous cases. So here, this is example, our student tested these different dust elements, and this is the power degradation happen in the panel, and this is the mass, dust mass density. As you can see here, the trend, it is the trend the same, but the effect is different. As example, ash, you can see for the same value of the same mass or the same density, have more effect, let me say, with respect to sawdust. So it is different from type to type. Now, usually people, when they do research on dust, they try to look to the ingredient. They go for particles, and they look to the physics and chemistry of the particles. I mean, physical properties and chemical properties. They do testing for the ingredient, to see what elements included, what are the percentage of participation of these elements in the total dust. And also, they look to the homogeneity, semi-homogeneity, or non-homogeneity distribution of dust themselves on the module. And they look also to the type. I mean, some of them is a circular type, some of them is, let me say, in this way, eagly, and have different, let me say, sharp legs and hands, and some of them spherical, and so type also have effect. Or they look also to the size, small size into large size. Each one have different effect. I mean, as example, small size when it's accumulated on dust, and you can see this in some of our publications. Now, it's easy to remove by blowers, as example, but it's have more effect on then comparing with large size, talking about less than 2 micron comparing with 50 or 60 micron. Also the shape, it could be smooth like this one, or it could be sharp like this one. You may say, okay, what if it is sharp? But sharp, it's have another effect for the dust. Does not only preventing light from arriving to the cell, but also and making shadow, but also scratching the surface of the glass, and scattering will happen more. We lose more photons and more insulation, more pore reduction. The researcher, what they do actually, one of their way to judge the effect is by look to the daily and monthly efficiency losses. As example, here you can see here in Sohar, Oman, okay, because of it is near the beach, it's surrounded by the Al-Hajar mountain series. You can see here that the daily reduction is less than compared with Abu Dhabi as example. Okay, they suffer from dust more with respect to Sohar with Oman. And also we did some of our student research, they collected dust from these cities. And by the way, location is an issue, especially if we compare as example Sohar, where we have a large industrial area, with another location where they don't have industrial area. Definitely here we have more pollution, more carbon. So they measure the effect of dust on one entire year for different cities such as Shinas, Liwa, Sohar, to see the effect. You can see Liwa as example have higher effect and higher dust accumulation because it's near the Sohar industrial area. This is daily PV power losses. I'm trying to show you just samples of the comparison, how we compare the effect of dust for different cities. By the way, this comparison is not 100% accurate. Usually, it's comparing between different systems size. Okay, yes, we try to go to normalized value, different system size, different technology. Okay, but we try to focus more on the let me say not the same day, but we try to focus on the period itself. I mean, compare one losses for one day, or let me say as example 1 day here it's 1 month. Okay, you can see here in different countries for 1 month is different. And by the way, we try to make sure that the months are the same. I mean, summer is summer, winter is winter. Okay, so it's suppose as example here all of them in summer season. Now this dust is an issue. We have to mitigate, we have to reduce it, and there are different ways. Some of them here just general, let me say, classification with each one of these points. There is a lot of, some of them they have more than one direction. As example, natural cleaning. Natural cleaning, when rain is comes, clean in the desert, clean the surface of the PV. Wind, as example, in desert, the wind will blow to remove the particles. Melting the snow, as example. Or automatic cleaning, it could be automatic water spray, microcontroller service brushing, cleaning robots, as the situation in Hebri, as example. Or passive surface treatment, the hydrophilic or hydrophobic, both of them are coating, like putting like painting, but the PV in a way that to prevent the dust particles from accumulating on the PV itself surface. Or manual cleaning, as we do here. Some of the student research, they try cleaning using water jet, or they use water with the soft clothes and so on. So they at the end it's manually happening manually. You can see here manually, these are people doing cleaning, manual cleaning. This robot cleaning the PV, hair vacuum and hair water spray, they try to put it on the PV. Here ultrasonic, it's like applying high voltage on the panel itself do vibration when, especially when the dust is dry dust, not I mean mute or with the humid in desert area. And this is as I mentioned, the coating. And this is vehicles. Last week I was with my students in a trip to Qaba Suhar plant 25 mega, and I take this photo for the cleaning this vehicle with the cleaning similar to the one we use it to clean our vehicles. Anyway, they use this one. Now, modeling, you remember I mentioned at the beginning that the one diode model used to model the PV, and then people are working on this for more than 80 to 90 years. And it's the untouchable, let me say, model. Now we try to, in our research, to include the dust, because I mean, here it's an ideal circuit. Here they don't look to the dust. They measure the solar radiation and they and make it as input to the circuit, and then they design. And most of the software available today, they consider this model in their design. We propose a new model by looking to the ingredient. As example, you collect the dust in a location in Sohar. We go for the XRD to check the ingredient. And when we check the ingredient, we try to focus on the highest, main 3 to 4 highest, let me say, percentage, which could be in the range of 90 to 94%. 4%, sorry, I'm lecturing from the morning. So these are our targets. As example, as SiO2, CaO, these are our target. What we did at that time, we try to check the effect of each one separately. We brought SiO2, we brought CaO, and we check their effect on in an indoor experiment to see how much their effect with respect to the mass, to the dust density. I mean, if we put 5, how much from SiO2, how much this affect, the percentage of its effect on current voltage, and this is reflected on power and energy. And after we specify this, if we want to, let me say, design a system in a specific location, we know that these are the elements in their dust, and these are the effects. We did it already inside in indoor experiments. Then we try to take the effect, the parameters, and the weight of the elements within the dust to introduce it in this equation, which is Ig equal IPV 1 minus M, which is the total mass of the dust containing these elements, by A is the effect of each element, by K is the weight of each element, and this represents the input to the equation proposed by Shockley and his group. And this gives a wonderful, interesting results, because it's, you see here as example, we took different scenarios, different tests to make sure that to check the validity of our model. This is in the top is the curve, IV curve. This is current, this is voltage for the ideal model, using ideal model, which did not consider dust impact. But here, 3 cases, 3 tests, we try to change the percentages of the dust ingredients and introduce the new collection to our model, and take the measurement. Okay, take the measurement, compare the experimental work with the model results. You can see here test 1 as example, they are close. Test 2, they are close. Test 3, they are close, comparing with the ideal. Ideal will not change, will be regardless what is the ingredient, it is the same. Okay, and this show the importance of and the accuracy of our model. By the way, you may say, okay, why they are not identical? There are many reasons. One of the reasons is the other physical and chemical physical properties such as weight, shape, size, type, and so on. Now, for critical, I try here to summarize the critical let me say points related to the research. Okay, these are the dust characteristics and the properties. I mean, as you know, for the properties we have accumulation rate, size, shape, optical, electrocyte deposit, behavior. All of this affects the the current voltage power in different way. It have to be considered, and it's related to the location and to the environment. It's important to consider them. Many of people investing in solar watt, especially in the Middle East, they don't consider these. And this is important to be reflected on selecting the suitable cleaning methods. What happened today, most of the investors or people working in the field of solar photovoltaic, they try to broad a method. I mean, as example, robot or let me say a brush, or without I mean any, let me say, justified scientific reason. They don't know about the dust in the location. Just this is the option given to them, and they try to select it, which is wrong, because this will reflect on how long will the system will work, how optimum the system will work, and what are the losses, what are losses on the in term of power, efficiency, energy, cost, let me say, or profits in general. So you cannot copy paste, let me say, directly an experience or experiment happened somewhere else in the world to use it in Oman and Sohar is different from Ibri as example. Main dust pollutant type also is important. I mean, the location will specify what is near the location. Is it there are industrial area, refinery, highway, or what is there? And type or methodology of cleaning is important, as I mentioned, but it's you see some projects, photovoltaic projects in the region. What happened is they fail because they did not consider dust impact, and when they come to cleaning, it was costly, especially if it required water. So this is an important, let me say, element to need to be investigated. People, they investigate only solar radiation in the location. We need to investigate dust and see their characteristics for at least 1 year to know what type of cleaning methods, what type of, let me say, how it look like the frequency of cleaning. Is it every couple of days? Is it weekly? Is it bi-weekly? Is it monthly? And so on. Okay. Also, the surfactant we use, I mean, based on the dust type, surfactant is a material, or let me say, particles, we put them in water to use to make sure that they clean the panel from type of dust. I mean, if it is near, let me say, places where there is bird drops which is stick to the panel, then we need specific, not normal water. It's not enough to clean the panel. Also, the cleaning periodic is important. I mean, imagine in Abu Dhabi they clean every 3 days the PV panel. The CSP, concentrated solar panel, they clean every couple of days, which is costly. It's really costly. Weekly clearing is in some places is essential, while Suhar, as example, monthly is fine. Okay, if it is dry, let me say, dust is different from if there is humidity. And by the way, some places when it's humid, it's not advisable to go for cleaning. They supposed to wait until it gets warm, and then no more, it become dry, and then they can do the cleaning. Considering other, let me say, environmental part is important also, and related to the impact of that, and this is also reflected on the cleaning. I think research and development in nanotechnology and meteorology still is important to reduce the impact of dust. Yes, may add extra costs on the PV itself, but this will not be an issue, especially today. The cost of solar photovoltaic is very low, talking about the range between $0.50 to $1 per watt. And optimization method for water usage is important in the places where we use water, and we have to consider that there is power to be consumed by the pump to push this water in the hose and the pipe. And now also it's important to have sensor system. This is many power plants today, they put sensor system and they check if there is a specific location, a part of the power plant need cleaning because there is dust accumulated on. This is happening in most of the used technology today. Now, the prospect I can summarize here is generalized dust model still a research gap need to be filled. yes, we propose one of the most accurate models today used by researcher, but this is not still enough. It's focused more on the homogeneous distribution of dust. It's still a dilemma, by the way. Dust modeling is a dilemma, and researchers still looking to find a model which generalized can be used everywhere. Some tests still are, let me say, not standardized. I mean, people use it different way. Okay, as example, how we measure the sampling of dust accumulated samples. There are different way used by researcher. There is no standard way. Sampling time is not standard. Some of them take every second, every minute, every 10 minutes, every 15, every 30 minutes, which is make a difference. Cleaning frequency is still, there is no clear, let me say, formula specifies related to many terms. Dust homogeneity, as I mentioned, homogeneous, non-homogeneous, semi-homogeneous, and so this is affecting because you don't expect how it look like that dust when it's accumulated on the PV panel. Okay, within the same, on the same panel within the same day, and from time to time, every second when wind blowing, it change the distribution of this particles. Sampling time as example also. Dust proposed model must be considered parameters beside mass, such as size, shape, ingredient, weight, distribution uniformity. All these system orientation, all these are not considered. By the way, most of the research conducted on the PV try to look from one side of view, which is not give a clear, idea about the full picture. We have to look from more than side of view. I mean, okay, you are interested in investigating dust on PV, but at the same time, add dust with temperature, dust with humidity, dust with wind. See, dust with temperature and humidity at the same time. See the effects. The correlation will be different and give you impression about what is the contribution of dust with respect to other variables. Including these models is important in software. Today, most of the software try to add, let me say, to consider the effect of dust by adding just percentage of reduction, which is different from researcher to researcher and from region to region. Some of them they supposed to that the reduction is 5%, 10%, and so on. So, as example, in Homer, they have this facility or property. So it's still not scientifically justified and do not give accurate design because it may give over sizing or undersizing. Generalized model is a research gap in the field, and if we have a general model, we can use it everywhere in our global. Now, the conclusion is, as I mentioned here through the discussion, that dust is one of the top and important problem facing utilizing photovoltaic panels, and it should not be considered just by looking to the dust density, type, pollutant themselves, size, shape. All of these need to be considered at the same time and to come up with a model which could be the generalized model people looking for. Also, there is no general standard for testing the solar photovoltaic. Even I mentioned for indoor and outdoor experimental setup, but there is no general, let me say, instructions by international bodies which specify the basis for researchers to investigate this problem, which is dust impact on photovoltaic. And finally, is the dust impact on photovoltaic highly reflected on the optimum sizing of the PV module of the PV system and on the technical and economical aspect. These are some of the references I used in the presentation. Some samples of our publications in the last 2 decades related only to dust. This is only dust impact. You can find them, search them in Scopus, you will find many of our publications are there. And if you would like to follow me on social media or scientific media, please find these are my addresses. This is my contact address. If you are interested to have a chat or some of our publications, you can find them in my website also most of the publication on my website. And thank you very much for listening. The mic back to you, Dr. Man. I'm waiting to have the questions and receive the questions from
Thank
you
you.
and
Thank
your
you very
colleagues.
much, Dr. Hussein, for this very informative and very interesting lecture on the hot topic that is the effect of the dust on the photovoltaic systems. Actually, it was really interesting to me. And I can see you have done significant contribution toward this field, especially for the effort dedicated to investigate many areas here in Oman. Okay, so I'd like now to open the floor for Q&A. So if you have any questions, please, you can just use you can just raise your hand, and then we can you can feel free to use the mic. If you have any question, please feel free to use the mic. Okay, so while we are waiting for the other audience, just if you have something in mind, I just would like here to ask Dr. Hussein regarding the dust. It was very interesting to see that you have not, you did not only consider the particle size of the dust, but also you considered the types of the dust as well as the shape of the dust. So for the shape of the dust, Dr. Hussein, did you characterize the shapes for the dust available here in Oman, or you have just made this one just as a part of? Did you shed light on this on the shape?
Yeah. In some of our conducted research, we try to focus even with limited, let me say, facilities for this type, but at least we try to monitor through the microscopic let me say images to see how it look like the dust shape. Is it sharp? Is it have different pins? And we tested samples taken from particularly the north of Oman cities, from Muscat to Masandam, to see their type and try to test in indoor test to see their effects. As I mentioned, one of the problem is not is the scratching of when it is sharp, it's scratching the panel, the glass, and this will make scattering for the light. We lose photons, we lose lights, then we lose power. And the other issue is when some of them, it's like a diamond, they make a scatter themselves without scratching. I mean, when the light come to them, it's like a diamond. They make a scatter to the light, and we lose again. So this is the only, let me say, test we did for the related to the shape. But I think researchers they have more effort in this. I mean, I'm reading about this. They have more effect, but still, it's part of the package. The main part is the dust accumulation density itself, the density, and the other issue is the element, shape, size, blah blah blah. Yeah.
Okay. So while these the parameters that should to consider when you have the study on the effect of the dust. Okay, so let's say the mitigation types for this dust. Do we need to let's say to consider, let's say, the type of the shape, the type of the dust while you select the mitigation method for the dust?
Yeah, I totally agree with you, Dr. Mahan. We have to consider this. At least, let's consider. If we don't consider the shape and size, we don't go deeply in this on this level. At least let's consider the dust accumulation and deposit on the panel for entire year, and daily monitor them before we establish, let me say, or install our solar plant. What happens is in the region, they come directly. They investigate directly. They don't look to this. Maybe they look to the solar radiation itself, but nobody do in general. Nobody do such research or such studies before they, and later they face the problem. because I mean, as I mentioned, in Abu Dhabi, it was a problem, and they established their systems and they come to let me say try to fix this problem in one way or another, and which is reflected on the economic side of you, and they lose rather than they go to profit. So the same, we have to avoid this in Oman. Now we are looking, we read in media that there is a new plants coming in Duqm, in Munah, and Adam, and so. But if they don't do this later on, they will face the problem. I've been talking about this for 2 decades, but I mean, I don't see that people are still interested in the Middle East in having such studies before they go for power plants, which will make difference if they consider it. I'm sure that will make difference. Yeah.
Okay, Dr. Hussein, last question from my side. What do you recommend, let's say, for, let's say, next or let's say potential research to explore on the dust, let's say, is particularly dedicated here to Oman?
Well, some of the research we did here in the on the north of Oman, only these cities, which is far from desert area. I mean, now the new direction they are looking to have, they have already in Ibri, near desert area, and they are interested in have Munah and Adam and Duqum, which is also a desert, but near the sea, and there is no mountains there to surround them. The temperature is high. It's really interesting. If researchers try to investigate the impact of this, considering at the same time temperature, because when the dust particles get heated, it's have also different effect. So I advise the investigation. This is, I mean, very important and helpful for the organization which will establish these systems for general research in related to this. As you mentioned your question, first question, size and shape are important. Still, people are investigating this. And the third point could be mentioned here is the dilemma, which is the modeling for dust. For a long time back, I read articles back to 1960 about dust, and studies happened conducted in Kingdom of Saudi Arabia, in Kuwait, in Algeria, in Egypt, in Iraq. But at that time, they've been investigating till today. There is no model. There is no model, general model. All models are case studies or partially can be give an impression about the dust impact. So model is an research gap. I advise students to work on them. Yes.
Okay. Thank you so much, Dr. Hussein, for these tips on the promising research areas where maybe our students, our colleagues, maybe they can explore later. Okay, so if you have any question, guys, please feel free to ask. Okay, so it seems no more questions. Okay, I would like to take this opportunity to sincerely thanking Dr. Hussein for for giving this time and to deliver this lecture. This is not the first lecture. Also, Dr. Hussein has delivered another lecture last year. And inshallah, also for sure, we are going to keep in touch to have more sessions and to get in touch with Dr. Hussein to share his extensive research experience with the young researchers, with the students, with all people who are interested in the renewable energy research. And we can see this sector is growing exponentially here in Oman, and there are so many researchers are looking forward to enhance and to improve their knowledge, their skills, and to gain new tools. And one of the best routes in order to gain all this knowledge, it is to get in touch with the people, with expert people who have spent many years in the research. So this can be considered as a shortcut for those who are interested to have like very quick startup and to ensure they will start from where the other people have ended. Thank you, Dr. Hussein. Thank you so
Thank
much.
you very much. Thank you very much. Have a
thank
good
you
day.
all for your. Yes, please, Dr. Hussein.
Thank you very much for inviting me. I look forward for more collaboration. Thank you for attending, for people attended our session. I'm looking forward for another session in the future. Thank you.
Absolutely. Thank you so much, Dr. Hussein.
Thank you. Bye-bye.
Thank you. Salam
Have a good day. Alaikum
You too. Thank you. Salam alaikum.
alaikum.